Right, resistivity. So, who remembers the formula at least? R equals rho L over A. So you have rho equals RA over L. So you could say it is the I don't know. I'm not sure that's the best way to say it. Let me have a look. I'll cheat. So I could say it's the resistance area per unit length. Yes. Well, if you look here, yeah, this would be ohms meters squared per meter. So I think also it might be useful to say that resistance is proportional to length over area. So the resistivity is a proportional constant as well. Here, Wikipedia will help us. Hang on, it's getting there. Oh, well, we'll come back to this. We'll come back to it, okay? But basically, the bigger the resistivity, the more resistance in the material, and the smaller, of course, the less resistance. I just don't know the sentence that expresses this nicely. Oh well. You can check your phone later, okay? Right, so let's have a look at the calculation part. A 2 meter length of wire with cross-section, resistance 10, the diameter is that, the term of the diameter. Right, okay, so that's not too bad. So can you just write these numbers down for me? So we have L is 2, R is 10, and resistivity is 1.1 times 10 to the minus 6. You have those, just the numbers, yeah? Okay. So let's do the calculation. Okay, so what's the R? 2. 10, thank you. And what's the next thing we know? Is, and that is 1.1. Okay, so we have the formula R equals rho L over A. So I can get the A is rho L over R. So the area I can find 1.1 times 10 to the power minus 6 times 2 divided by 10. So the area is 2.2 times 10 to the minus 7. But if it's a circle, what's the formula for area? Pi r squared. So if I divide by pi, and then if I square root, I get R equals 2.646 times 10 to the minus 4. But they don't want the R, they want the diameter, which is 2R. So the answer is 0.5 0.29 millimeters. That's the diameter. Do I have resistivity? I do not. Okay. Is that okay? Next now. The wire is being used here in this potential divider circuit. So this wire A to B is the wire from this part here. And there's 12 volts here and there's 3 volts. So we have 12 and a 3 and an L1 and an L2. And the question is, what is L2? Okay. So if I go here now, there's here in L1 and then here in L2, and then what they're saying is here is 12 volts, thank you, and then here 3 volts, and they want this L here. So I think if I use Ohm's law, now hang on, let me just check something here. Did they say the same length in total? Yeah, it's the same wire. So we know what. We calculated the resistance. Yeah, we know what the total resistance is. What is it? 10. Did they say that?
Yeah, it shows the spec.
So I could say V equals I or, so then I equals V over or, which equals 12 over 10, which equals 1.2. That's the I. So what you have here is you have the I is 1.2 amps. 1.2, 1.2, 1.2, 1.2. Now I use Ohm's law here. So V equals I or. So what's the, I want the or now. Or equals V over I. What's the V? 3. And what's the I? 1.2. So the or is 3 divided by 1.2, which is 2.5. Now, they want the length. So what formula could I use next? Yeah, or equals rho L over A. So we know the or is 2.5. We know the, well, let me rewrite it. So we have L equals or A over rho. Okay, the or is 2.5. I have the area from previously, don't I? What is the area? It is 2.7 times 10 to the power minus 7. And can you tell me what was the resistivity? What was it? Minus 6. So this becomes, if I put in my numbers, 0.61 volts. What? Sorry, thank you. Length we usually measure in meters, yes. 0.61 4 meters. Now, there is another way to do this one. In fact, for these circuits, if this is 3 volts, then you know that here this should be 9 volts. So the you can use some basic logic here. The voltage here is twice as big as the voltage here. Therefore, the voltage here is 3 times bigger than the voltage here. Therefore, the resistance here is 3 times bigger than the resistance here. Therefore, the length here is 3 times the length here. So if this is 3x and this is x, I add them together, what do I get? 4x. But what is the total length? It's 1.5? No, 2 meters. So then x equals 2 over 4, 0.5. So it's not quite the same. I do wonder if I type my numbers incorrectly here. Let me check that. 2.5 times 2.7 times 10 to the minus 7. And what's the resistivity? 1.1 times 10 to the minus 6.
So the quicker way is more accurate.
No. Maybe. I don't know. Oh, hang on. Sorry. Well, so I don't know, something went wrong. Something went wrong. I will tell you how to. Which number is this? Version 1. Right, just give me a few seconds. Was that answer right for the last part? 5.9, did I say what I got?
No, 0.5.
Yeah. So my second answer, the second way I did it was right, but my answer for the first one should also work, which means I'm doing something stupid with my calculator here. Don't know. The answer should be the same. I don't know why it's not, and it makes me unhappy. Okay. We have to use this method here.
How do you get the 2 for x equal to?
Because the question tells us that this distance here is 2 meters. So I call this piece 3x and I call this piece x.
And what method is the answer?
The answer used this method. But I feel like both should have worked. So I feel like I'm doing something stupid on my calculator for this one here. But I don't know what. Is it possible, you know what the problem might be? Hey. The problem might be this here. I don't know if I round it off too much or something. You know what I mean? 1.1 times 10 to the minus 6 times 2 divided by 10. This number's wrong. This is the problem. This should have been 2.2. That should have been 2.2. So that means the reason the answers are different is because my area is wrong. Here I should have been using 2.2 times 10 to the minus 7. So if I change this to 2.2, the same. Yeah, I knew it was something stupid with the calculator. There should have been the same answer, okay? So now they're the same, so we're happy. Alright. Can we go to the next one now? Okay. Now it says, the next one is a different question. A 5 ohm resistor is connected across the output in the potential divider. Determine the potential difference across this resistor if L2 is kept the same. Right, so what they're saying is a 5 ohm resistor is connected across here. So you put a 5 ohm resistor here. Okay, so I'll just draw that in now. Let me draw that again. So we have 12 volts, and we have resistor, and we have resistor, and then we have here another resistor. And they tell us that this one here is 5. Now, you know the total between these two, what is it? 10. But you could use your formula to work out the answer for each of these. But the same rule applies. If this is 3 times bigger than this, you could do your trick with the x again. So this is 3x, this is x. The total is 4x, which should be 10 ohms. So then x is 10 over 4, 5 over 2, 2.5. So you get here, this is 7.5 and this is 2.5. Now if you're not happy with that, you can just use this formula here. Okay, because do you know the resistivity? Yes. Do you know the area? Yes. And do you know the length? Yes, that was the last question.
So those two resistance doesn't change.
The same distance, yeah. So this is 0.5, didn't we say?
The resistance, they don't change. You put 5 ohm, another 5 ohm resistance.
No, it doesn't change. The voltages would change though, possibly, yeah.
Resistance, they never change.
No, it shouldn't.
You just have to.
No, is the answer. So the question is, what is the voltage across the resistor if L2 is kept the same? Okay, so what they would like to know here is what is this voltage here. Now, in this one here, we should work out the total resistance first. So because these are in parallel, we have 1 over R equals 1 over 2.5 plus 1 over 5, which equals 3 over 5, thank you. So then the R equals 5 over 3. That's for these two. But then we have to add it to this one because it's in series.
Why I can't to add in the beginning?
Yeah, why can't you add these two?
Yeah.
I think Ugo asked me something like that last with the capacitors as well. About if we should add the series first or the parallel first. When he did it, he got the same answer, so it might not matter. But for me, I feel safer if I do the parallel first and then the series second. So do the parallel ones first and then add that to the series one. So I'll do these ones first so they're in parallel. It comes in at 9.17. So we can use Ohm's law again. And we get I equals V over R, which is 12 over 9.17, which is 1.31 amps. So that's good. We know that it's 1.31 amps. So, let me see, we would like the voltage here. So the voltage V equals I OR. We know the OR, so we're finished if we know the I. Is the I 1.5 here? 1.31 here? It's not, because look what happens. It's 1.3, 1.3, 1.3, but then what happens here? It splits, doesn't it? So it's not 1.3. So we could use Kirchhoff. Here is 1.3, here is I1, and here is I2. So we know that 1.3 minus I1 minus I2 equals 0. We can also use the loop rule. What loop would you like to take? We'll go around this big loop here. We have 12 minus I or minus can you still see I or oh wait, no, the I is not 1.3. What's the I here for this one? I2, thank you. I2 2.5. That's great, because here we can get the I2. So the I2 will be 12 minus 1.31 times 7.5 divided by 2.5. So the I2 is 0.87. If I put that in here, I can get the I1. So the I1 is 0.44. Now I can use the Ohm's law here. V equals I OR. So that equals I1 multiplied 5. So that equals 0.44 multiplied 5. So finally I have my answer, 2.2 volts. Okay. Now what's really nice is, because of the way I did it, because of Kirchhoff's law, I actually not only answered the first part, I also answered the next part and the next part, because the next part says what is the current in AC and what is the current in CB. So that is what is I1 and what is I2. So because of the way I did it, I actually did these two parts first, and then I got this answer. So I got 3, 5, 7 marks the way I did it in one go. There are other ways to do it, but I really like Kirchhoff, and it's good here because you do all three at the same time. This is why I like it. So now, because we use Kirchhoff, we'll finish this, and now we're on to this question, which, look what this is. It's, if I zoom out a little bit, this is a Kirchhoff question. They want I1, I2, and E. I1, I2, and E. So how many junctions here? There's two junctions. Which junction we'll use? We use this junction. So what's going into this junction? 2.1. Can you see it there? Yeah. And what's coming out of the junction? I1, I2. So what's our equation?
I1 plus I2.
Well, we do in first. So 2.1 minus I1 minus I2 equals 0. Now we'll take a loop. How many loops do we need to take here? 2. So we'll take a loop at the 10, and I recommend going down and down because, well, tell me why. Why do I recommend going down and not taking this loop, the loop that goes up here? Yeah, so here you don't have an E1, you just have a 16, which is easier. What other loop should you take? I think maybe take a small loop, like maybe this loop here. I think. But you don't have to. You could have taken the other loop. You could then go up. you have many choices. Yeah, well, not many choices, sorry. You have 3 choices. So you need to make 2 of them.
How to find the energy?
The E? Yeah, what you do is, just like last time, you make 3 equations. Now last week it was I1, I2, I3. But today it will be I1, I2 and E. So it's the same, you know what I mean? Like instead of having I1, I2, E, I1, I2, I3, you have I1, I2, E. So the E is just another variable, like I1 and I2. So, look, before we finish really quick, why don't we make the equations, we just say them out loud. So junction, 2.1 minus I1 minus I2 equals 0. Yeah? Now let's take the big loop. So I see 10 minus 2.1 times 8 minus, plus 16 minus 6I2 minus 2I2 equals 0. And let's take the smaller loop on the inside. So now I have 10 minus 2.1 times 8 plus E1 minus 4I1 minus 2. Oh, we were wrong. Earlier we said minus 2I2. No. It's minus 2.1. Yeah, can you see that? I misspoke. I said here is I2. It's not. What is here? It's 2.1. Not, because the I1 and the I2 come together here and they'll make 2.1. So I should have said minus 2 times 2.1. Okay? So you have 3 equations and 3 unknowns. The 3 unknowns are I1, I2 and E1. Yeah. And what I'd like you to do, actually, for the weekend, is I want you to do this question, just to practice. And do the whole question from the start, from the definition, which you can get on Wikipedia. Okay. Do this whole question. And the reason I want you to do it is I want you to see how long it takes you to do this section B question. Because it should take you maybe 25 minutes at most, maximum, to do it. This is in the 2014 exam, last year's exam, last question in the exam. And it could be in the semester 1 exam as well. Yeah. Everything. Yeah. Mechanics, electricity, yeah.
And that's will we do any other topic?
Oh yes, we'll start next week. Right, is it?
That will be in the
Yes, everything, yeah. Alright.